Right now we are on page 10 of your lecture notes, discussing on how to find the area between the curve and the y-axis. So for a region R enclosed by the function x in terms of y, in this case written as x equals to h of y, and the right side of the y-axis, the lines y equals to a and y equals to b, the area of region R can be found by integrating from a to b x dy, where x is actually your hy. So essentially you are integrating an expression in terms of y with respect to y. So for your lower limit, it will be the lower bound, y equals to a, and your upper limit, b, will be your upper bound, y equals to b. Take note that h of y has to be at least 0. In other words, the section of the graph has to be on the right side of y-axis. Alright, let's flip to page 15 to look at example 8. Okay, example 8 says this: find the exact area bounded by the y-axis the curve y equals to e to the power of x and the line y equals to 4. So essentially what the question wants us to find is this area here. So if you want to find the area directly, we can actually look at this function here. So if we are able to find this function x in terms of y, then you are able to integrate it directly. So how do I write x in terms of y? Simply, I take ln on both sides. I'll get x equals to ln of y. So integrating with respect to y, what I have now is, I know that my lower bound is 1, my upper bound is 4, of which function? Of this particular function y equals to e to the power x, but now being written as x in terms of y. So I place my ln y here and integrate with respect to y. So based on what you have learned under the topic of integration technique, you know that I can't integrate ln directly. So what I can do now is, I see it as 1 times ln of y. So subsequently, I move on to integrate by parts. So this step to this step, I will not explain in detail. So after integrating by parts, I realize that this value here essentially is 4 of ln 4. And in fact, this whole guy here is actually a 1, so integrating 1 shouldn't have any issue. And finally, you arrive at this answer for this part here, and arriving at the final answer of 8 ln 2 minus 3. So sometimes we can go by the indirect approach by finding the area of A indirectly. So what do I mean by that? So you can actually see that to find the area of A is the same as that when I actually take the area of this whole rectangle here minus away the region B, which I'm going to shade in pink. So basically now I'm going to take the area of this rectangle here minus away the region shaded in pink. So how do I find the area of this rectangle in blue? I'm going to take the height times the length. So the height is obviously of a length of 4 units. And the length itself, although it's written as ln 4 here, how do we actually get ln 4? Simply we sub in when y is 4 and look for the x value. So when y is 4, take ln on both sides, I'll get x equals to ln 4. That's the reason why this is ln 4. So the area of this rectangle is simply 4 times ln 4. So I need to deduct away the area shaded in pink. So what I'm going to do now is I integrate. What is the lower limit? The lower limit is 0. The upper limit, ln of 4, of which function? The function y equals to e to the power of x. So it's just e to the power of x here, integrating with respect to x. So essentially, this integral here is what you've seen here. And finally, working out the next few steps, substituting ln 4 int minus away, substituting 0 into this expression, and doing some calculation, you end up having this as the answer, which is the same as method 1, 8 ln 2 minus 3.